All right, so it's billed as Modbus over 485 lesson plan is actually kind of the unplanned lesson is what I'm talking about. This semester, our grant, we were supposed to do four courses plus one that was rewritten, and we started teaching them all this year. So I had like 15 hours a week of stuff that was unprepared that I had to come up with. And so I was working, you know, uh, um, just ahead of the students most of the time. And sometimes behind the students, they would actually call the company or something if I got stuck on and do the research themselves. So anyway, what I'm generally trying to do as I am writing these courses is first thing is none of the instructors really have any background in BAT. We have some that have HVAC. We had some, well, okay, the two of us that started, I'm electronics, and Andy Smart was HVAC. He left. He got replaced by an electrical systems person. We just had someone join who's HVAC. But the point is that as these courses get handed on to other people, you can't count on them knowing anything about what you're doing, really, right? So the first thing as I'm building these courses is I try and do something that's teach the teacher, right? What should you be reading before you try and do this class? What videos? Just something to give people something to hang on to instead of. I don't like to do a PowerPoint that gets handed to an instructor to go through necessarily, because you can convince yourself that you know what the PowerPoint means, and then when you get into the class, it's like, oh, scan through it, yeah, sure, and then you get in the class and you don't know what it is really. So my idea is to give a background for the instructors to know something about the topic, hopefully more than the students will know at the end. And then, so give them references, give them notes on what we learned as we went through, or problems we ran into, or points where it seems like it's a problem, but you really want to leave it there because it's good for the students to learn from this problem. And I think Jenny was saying this also. This is just me winging it, right? I've written several courses, but this is a different field and a different area, so I don't really know what's good a lot of times. And I'm learning, but this is just kind of the plan. So the first thing is to do the teach the teacher. Then when you're teaching the student, it's like give the big picture, how this exercise fits into BAT in general, the specific goal, the pieces they should be given to fit together to make a working system. But what I am not doing is like giving step-by-step instructions. Everything's geared around a lab, right? But in my lab document, I'm not necessarily giving step-by-step instructions. It's like, okay, when you're out in the field, there's not going to be this little manual that gives you the step-by-step instructions. You have to know how to go and find the information yourself. So there's like a pre-lab lecture where I go over the information. So in this one I would do, well, what is EIA 485? It's a twisted pair. You have a range of -7 to 12 volts. You have to have your end-of-line determinations. I'm not teaching it to y'all here. I'm just saying that's what I would do. Talk about at this point the students had already done MST, so they'd already seen 485. Talk about how it's a little different than the BACnet MSTP, right? So we have one master, many slaves. The master is the initiator. Slaves can only respond. The MSTP, it's the master moves around, right? So this is different in that sense. Then go through and define the communication parameters that you have to have. Each device has to have a device ID. You have to have the data rate defined. The number of bits refers to data number of bits. Each data, so an 8-bit character has can have a parity. You can determine how many stop bits determine that character. So each character can come out with, you can define even parity or odd parity. You can define no parity. You can define 1 stop bit, 2 stop bits. That's kind of the Modbus framework, right? That's part of the parameters that define your communication. So, so we did, what we had was, let me see if I can find it here. I have the wrong glasses on. Yeah. So we had the sensor that could be either the BAGnet MSTP or Modbus. So we used it for both of the exercises, the same sensor. So they didn't have to learn a new sensor. You know, they could use what they've already learned. It wasn't all brand new. But I didn't tell them. I said, you need to look at, what do you need to, in the lecture, it's like you need to look at, how do you set the parity? How do you choose Modbus? How do you do, you know, but then go read the document and see yourself how you have to do this on this sensor, right? And so the documents are available, right, before class, but usually it's like 10 minutes in class that they're reading this and trying to figure it out and all of that. So for this one, they have to hook up the power, you know, figure out how to hook up power. The end of line termination here is a jumper that they can set. We have covered binary, so the fact that the address is done here with binary dip switch is something that they should be able to do, right? Be able to figure out what the actual number is. So but it's like, be careful of the details. It's the least significant bit is not the top bit. It's like in between here, right? At this point, I know I'm not giving you a good thing to follow on the screen, but all of this is something they need to work with. So the data sheet itself tells them how to set all of this up, and if they get stuck, then somebody, you know, I'm there to answer questions, but the idea is they need to be able to do it themselves, right? Okay, and this is one of those questions that is a real question from me to you. Then I give them the EasyIO document. Let me back up. We used the EasyIO FS32 as the controller for this. We have contemporary controls in our lab. We had the BAS Pi, the students buy those. We also have EasyIO. We have lots of controllers, open source controllers. We use this one because it can take an MSTP or a Modbus signal in directly, right? The first set here is for MSTP. This set is for the Modbus. So we didn't have to go through a gateway or anything to get to the controller. And it was really easy to set up. We have the contemporary controls gateway, and I still don't quite know how to set it up for the Modbus because it depends on having a actual like template profile file. And one of my students, again, my students are great at answering my questions. One of my students went through at the very end of the semester and figured out how to do it, but I haven't gone back and looked at it yet. But this was really easy to set up, and it had, you know, online, this came, I guess when you buy the EasyIO, you get a dump of documents, and this was one of the documents that got dumped with it. And it goes through and it tells you everything you need to do to set up for the Modbus. It doesn't tell you the parameters you need necessarily, but all the information is there. So you can set the baud rate, you set the number of data bits, the stop bits, the parity, and you have to make it match what's on the sensor side, right, that you set up on the sensor side. But my question is, like, if we are publishing anything, I guess that's one thing in thinking about like publishing. Once I get all these classes done, I'm supposed to put them up on the BAS Center website, right? And but if how much is fair use? Does anybody have any experience with doing that? Like, I could not put this document up there. I could maybe put a link to it or just refer to it, but it is copyrighted, right? And the
If it's public on Google, I mean, you gotta go with the number one teacher rule.
say again,
The number one teacher rule that you have to abide by.
what's that?
Ask for forgiveness.
Oh, well, yeah. Yeah.
And then some who would help, because I'm running the same kind of thing. You know, you're supposed, I don't know, Creative Commons kind of.
Or you just call the company. Most of those company people will be good.
I would propose two solutions for this. One, you could reference the document as stated and include the PDF document, because these are, while they are copyrighted documents, they are freely available documents, because they are the documents that support the controls.
Uh-huh.
So they might get a little bit irritated if you started taking sections of it and putting it in other documents. But as long as you provide their original document with it, I don't think they'll care.
Okay.
Or actually, I know they won't care. It's possible that they wouldn't even care about any copyright infringement, since it's now JCI's property and they are not doing anything with it.
Yeah.
The other option would be you could take the applicable parts of that manual and literally go in and do your own screen grabs, and you could retype it.
Yeah, I don't want to do that.
Lot more work, though.
Yeah, that's the point is, you know, like I said, I had 15 empty hours every week to fill this semester. Everything I could find online already there, you know, was gold, right? This was something I didn't have to go through. I mean, I had to go through and make sure it worked. Sometimes I didn't even do that, right? It's like, here, do this document. But so, and like the reference that I had for the instructors is Chipkin, which is copyrighted, and it is a book you can actually buy, but it's also freely available on the internet. You know, it's a 70-something page. I'm not making money off
It
of
doesn't matter.
So, yeah, okay. I just wanted to get a little bit of feedback on that idea, because, I mean, the school itself is very adamant that you have to have written permission from something copyrighted. And it's like,
Well,
really?
that's what works cited pages are all about, right?
Say, guys?
Works cited pages. The whole concept, academic, citation, referencing.
Yeah, so, okay. So, good, I mean, you know, it's like, I was...
It's not your problem, it's their problem.
Okay, all right. All right, so anyway, so that was what we did, is used, at any point that I can, use something that's already available, right? And so they went through and set this up, and it worked, right? They used this document, they used I mean, it didn't work necessarily, you know, they had to work through it. If you've done, and most of you have done some kind of 485 maybe, it's like you do have to be very careful about terminations and not running in the same conduit with your power, you know, all of those kind of things. You have to be very careful to get it to work, but it did work fairly easily. I was also teaching a troubleshooting class this semester for my electronics students with oscilloscopes, and let's see. Yeah, let me go ahead and do that. So I write up, whoops, try that again. So I write up the lab document. I give them a pretty good lab document to go by, but like I say, I don't write it out step by step. It's like, go look at this, go look at that, read it, figure it out. One thing we could have done was try to We only did it with one sensor, so they had their controller and their sensor, which is pretty lame for Modbus, right? So we didn't have time to extend it. Next time I teach it, hopefully we'll do at least 2. But what I did do instead is I did it with oscilloscopes. I was doing troubleshooting. I came into the BAT lab with my oscilloscope, and that's just a general picture of an oscilloscope. And the students were like, cool, what is that? Can we learn that? And so that became the unplanned lesson, right, is to go in and look at the Modbus signal with an oscilloscope. We had a pretty significant 60 hertz curve noise on it, right? And the cool thing is, it was still working with that 60 hertz noise on it, right? But you didn't know that noise was there until we actually plugged the oscilloscope in, right? And so I intend to go in and explore this a little more, like the Chipkin reference goes and talks about, you can look at how the noise is affected when you lose one of your end-of-line resistors, or, there's lots of things you could look at with the oscilloscope and have a better feel for what's actually on the signal. The thing is, on the Modbus, like we have this noise level behind it. Okay, so I'm at 1 volt per division here, so my noise level is my actual signal level going here is from about, let's see, 1, 2, 3, 4, 5, 6, 7 volts peak to peak. Modbus range is -7 to 12. I'm well within the range, right? So that's why it worked. But what if you put your oscilloscope on here and your noise level was actually -7 to plus, or -6 to +6 or something like that. And so you were like on the hairy edge of it actually working. And once you add the signal on, it might work or it might not work, right? So the oscilloscope gives you that information about it, whereas if you're just saying, oh, it showed up in my controller and it's great, and then 2 weeks later, situation changes a little bit and you just get a little bit more, if you're on the hairy edge or not when you use the oscilloscope. But this is not something that's usually, correct me if I'm wrong, it's not something that BAT students usually work with, right? They were thrilled. My students were absolutely thrilled to be learning this. And they were like, oh, you see it on YouTube videos all the time and blah, 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 and I've always wondered what, and they were. Every one of them was like, yes, even the ones that usually are kind of like, oh, yeah, So that's why I wanted to do this, is to point this out. And I think, my opinion, that has not very much behind it, is that it's going to be more reasonable for BAT in the field technicians to have an oscilloscope. The one I'm using here is, a $4,000 lab bench equipment kind of thing. But you can get, the BAT student or techs are going to go into the field with a laptop usually, right? You can get a little box that's about that big that plugs into your laptop that is a good oscilloscope. This oscilloscope screen is your computer screen. It's like $200 or something for one of these analog 2 discovery units. So I think as time goes on, that's going to, oops, sorry.
I'll bring in one tomorrow.
Oh, you have one?
I do, because I have one when I was in the field. I also recently got a handheld multimeter type oscilloscope. It's also
Fluke has them.
Same price range, I'll bring it in.
Yeah, so.
One of the things, I'm curious, with your oscilloscope, you may have the ability to put masks on top of signals to decode them.
What do you mean masks?
A translator within the oscilloscope to note, that literally takes like a Modbus signal and acknowledge what this, spike means. If this is your quiz,
I don't think I have that. I mean, if I do, I don't know about it.
I know that's a capability with the laptop or the plug-in USB lunch for the laptop.
Okay.
And I've used that in the field with MacNet before, and that's a potential extension so that you can look at that MSTP signal and say, okay, this is where it's asking, what are you online? This is what it's talking about, these type of thing. It's really cool.
Mm-hmm. So, that's what I mean, I think it is really cool to be able to see what this one, let me see if I have another picture here, I think. So this is the call and response, right? The left side is the call, the second side is the response. And the blue is, so what we did is set it up two probes, right? One is the negative, one is the positive, the ground's tied together. And then apply the math function to it. So this looks like, I mean, the scale is screwy and everything, but this looks like what you get for when you look on YouTube or something for, oh, this is what your Modbus signal should look like, right? All square and nice. So that's the math of those two, the difference between those two, the two differential signals. And it looks good, right? You would think, oh, this is perfect, but in reality, you've got that wave on it that gets, and that demonstrates why you're doing twisted pair and differential signals, right? Is because that common noise is now gone. So when the thing came out to do a lesson plan, I had just come off of doing this, and I was like, yes, this was so much fun, and they were all so happy about it. So that's why I chose to do this, right? It's not that I'm any expert in any of this. It's just it worked and it was fun, and if you can do something like that, you know, that's out of their norm, or yes, sir.
You played around on modbus.org?
No.
That's the site everybody should look at. Chip gets referenced in there. There's different polling devices that will allow you to key in their number, and it'll give you the value off of it. It's like it's called Modbus poll.
Mm-hmm.
But they have a lot of different resources there. That's the nonprofit organization
For that.
Like backbenchers.org, it's the same thing. But
Yeah.
That's a good one.
Yeah. So yeah, I mean, this was like the end of the semester. It's like, I'm almost there. and this was EasyIO's document was already there. So we played with it some, but I haven't really studied Modbus that much. But certainly, modbus.org.
That's it. Yeah,
Yep.
It's got all kinds of resources.
Okay. And that's it. My time's up.